Good afternoon, I am Mr. Ish. Thank you for joining me for this video. We're looking here at this Pythagorean Theorem formula, a squared plus b squared equals c squared. We know it applies to right triangles. If you take the base a squared, the height b squared, you sum them both, you will get the hypotenuse c squared. We know this to be very applicable to right triangles. How can you go about verifying that indeed this relationship is true or that this formula is true? Remember, we're not proving how the formula forms, or we're not doing a proof for it. We're showing that this formula is indeed true, it is correct. How can we go about doing that verification? A good way, since we're looking at right triangles or something which relates to right triangles, is to use trigonometry, because trigonometry is the study of triangles. And a good approach here is to use the unit circle. The unit circle has a series of points, all of which combine to make your circle. Pick any point, and you know that point is going to have a certain x and y value. That x and y value represents a coordinate pair, and what you can do is from your center of your circle, you can generate a segment to that point, bring a line down and generate a right triangle. I will blow up this right triangle over here so you can see it. This right here is a certain angle by which I have generated this triangle. This angle could have literally been any angle from here, from 0 to 90. So long as we retain a 90-degree relationship, any angle could have been utilized for this data. But I have a certain base here, we'll call that A. I have a certain height, we'll call that B. And I have a certain hypotenuse, we'll call that C. The best way to verify that this identity or that this formula is true is to convert everything with regards to C, your hypotenuse variable. How can you do that? You can start one by one with each letter. Let's look at A and we'll convert that into terms of C. With regards to this angle theta, cosine of that angle is equal to adjacent over hypotenuse. You solve for A is equal to C cosine theta, and we've suddenly converted A into the C variable. With regards to B, sine of theta is equal to opposite over hypotenuse, B over C, and then B is equal to C sine theta, and we've converted B into the C variable. We need to verify what this is with regards to itself. We've looked at everything here with regards to a certain dimension. A has become that, B has become that, but let's verify C to be what it is. We can use a function such as secant. Secant theta is equal to hypotenuse over adjacent, C over A. And then with regards to this C is equal to A secant theta. But what exactly is A over here? A is equal to C, right? C cosine theta secant theta. Cosine and secant are reciprocal functions. Each is a reciprocal of the other. They can cancel out because you'll have cosine times 1 over cosine and it'll cancel out. So you're showing indeed C is equal to C. So we have very well shown that C is indeed a good variable for which to convert the other two into a good standard variable that we can utilize. Since we've done that, I want to remove this because now we need to bring some more numerical values in here. We need to bring some sort of relationship here with regards to theta. Let theta be equal to pi over 4, which is 45 degrees. You could have used any angle between 0 and 90. I'm using 45 because it's easy to handle. A 45, 45, 90 triangle has a 1, 1, root 2 trigonometric ratios. I know sine of 45 is equal to 1 over root 2. I know cosine of 45 is equal to 1 over root 2. We know that to be the case. Sine 45 is equal to cosine 45, which is equal to 1 over root 2. You can plug these in right over here. A here is equal to C of cosine of 45, which is C over root 2. B is equal to C of sine 45, which is C times 1 over root 2, which is equal to C over root 2. A is equal to C over root 2, B is equal to C over root 2, and I showed you very momentarily ago C was equal to C. These are all our relationships where everything has been converted into a single variable, A, B, C, into the C. How can we verify this to be true? The only way you can generate this relationship over here with regards to what you have is you would square the A, you would square the B, the sum of those would equal to that, and you'll see it. C over root 2 square plus C over root 2 square should equal C square. If this equals that, then we've shown that this is indeed true, and you will see it to be the case. C square over 2 plus C square over 2 is equal to C square. You have a half C square plus a half C square is a full C square. a 2c square over 2, which is really equal to a c square. So we've shown you c square is indeed equal to c square. This right here is equal to that. By showing you that this is equal to that, we've shown that this Pythagorean formula is indeed true, because the left side of the equation equals the right side, and that's a good technique or tactic to use to verify a certain formula where one side is equal to the other side. And we've done it by means of this trigonometric relationship here, utilizing theta as 45 degrees. You could have used 30, 60, 80, 10, 20, whatever, except with the decimals coming in play it would become a little messy. But with using 30, 60 or a 45, it's nice and clean because you have fractions all the way through and it's easier to manage. But that's it. Thank you for watching. Have a nice day.